at Square, doing Android things on the banking work stream. And today I'm going to be talking to you about Paparazzi. How many people have heard of Paparazzi before? Great. How many people are actually using it? Cool. I'm hoping this will change after this talk. My job at this point is to convince you of that. And so the title of the talk is Keeping Your Pixels Perfect, Paparazzi 1.0. I gave a version of this talk, I guess 2 years ago now, in DroidCon NYC, and we'll go over some of that journey again. But now we feel that the product is actually mature enough to be used by every app that's willing to try it out. We ship it on CI and every pull request that we commit to Cash App, and Square Register is currently looking to employ it as well. So yeah, if we can do it, so can you. So everyone's probably heard of Square from its open source culture, and people may wonder what exactly is Cash App. So Cash App is one product offering that's available in the US and UK only at the moment, which is why it's probably not very known here. But many of the engineers who have worked at Square that you're familiar with, like Jesse Wilson and Jake Wharton, currently work on the Cash App product, and so we're still the same company, but we're two different products. And so you can essentially think of them as the same, except from a GitHub domain perspective. And so Cash App's mission is to enable payments, allow consumers to send money to each other, but also take out short-term loans, enabling consumers to manage their money through banking, lending, investing, and Bitcoin services. So while you're familiar with Square's open source repository with such libraries as OKHDP, Retrofit, Leak Canary, Picasso, et cetera, the Cash App engineering team also has the same commitment to open source. And on the Cash Android team, we move very fast, and we expect the tooling to enable us to do so as well. And so when I joined the Cash team about 3.5 years ago, it was a pretty small team. This was around the time when Jake left originally to join Google, is when I joined the Cash team. And so we were really small, and we've since grown a lot. And as you can imagine, when you move from small teams to big teams, the velocity and the delivery, we still had those expectations to deliver on a 2-week cadence. And so how do you do that when you have onboarding and more people committing to the code base? On top of that, our design team is very really good at coming up with a design language, and they want to iterate just as fast as engineers do. And so we want to make sure that we don't regress in parts of the app if, for example, we apply a new styling to a new button or widget. And since that time, Jake has come back to Cash App, and so it's great to be working with him again. Okay, so let's say you're working on your next big feature, and design hands you over a Figma link to say, implement a new cash card design. And so as an Android developer, you're pretty familiar with working either in XML layouts or maybe now with Jetpack Compose, moving into composable functions. Maybe before even Compose came out, you still were kind of over XML layouts and we're using some sort of creating your view in code via many libraries. We offer one called Contour. Either way, if you were working in the IDE, you were probably trying to use the layout preview pane in Android Studio to take a quick look on how it was going. And only until recently would you necessarily see it as expected. What you may have seen sometimes is your view looking like this. And so that's a bummer. So now how can you actually get that feedback loop? Well, historically, you have had to build the app and then install it on a device or emulator. But of course, then you have to contend with Gradle. Depending on the size of your app and what features you enable and the modularity of your app, this may be anywhere from 30 seconds to over 10 minutes. And it's mainly because the Android toolchain is very complicated. This is an outdated diagram. It's even more complicated now, but some of the same components have been part of the Android build since day one. For example, resources and assets have to be merged and crunched, and any transitive library manifests from your AARs have to be processed and linked through a process called AAPT. And eventually will be packaged in a binary format in your APK. Your source files, of course, have to be compiled from first to class files and then to dex files in order to, and then possibly shrinked or desugared by R8. If you happen to still be using a transitive dependency that's using the old support libraries, then they'll need to be jetified. And then finally, you'll have to zip up the app into an APK and install it on the device or emulator. And while IDE support for things like instant run or apply changes tries to improve on that, it still takes a non-trivial time to just build this. And remember, the premise here is just to see that your view rendered correctly. Recently on Cash App, we engaged Gradle Enterprise and some of the dashboard utilities that it provides. And through a series of efforts with the team, we've been able to improve our build speeds quite a bit. But still, like, depending if when you start in the morning and you pull master, rebase on that and build, you're probably losing incremental compilation because of properties of the Kotlin plugin, basically, that causes that. I've talked about that at DroidCon Toronto on how Kotlin has an impact on build speeds, and so we all face this problem, even if you enable the latest flags. As a side note, I'll be talking a week at DroidCon London with Ruse from Gradle about how we were able to use Gradle Enterprise and Cash App, but that's just a quick side note plug. So now that you've built the APK and deployed it to the emulator, you can finally load it on your device. But now you have to find the screen. Maybe your app flow is server-driven. Maybe it's behind a feature flag. Maybe staging is down. And it's just getting, again, preventing you from getting to the screen you want to see. And if I haven't made the case by now, this is a terrible feedback loop. This problem isn't unique to the Cache team. Every one of you is facing this as an Android dev. So during a hack week back in March 2019, Jesse Wilson and I started digging around in Android sources to learn more about how the layout preview feature in Android Studio works. After digging around a bit, we copied some of the plugin jars that were loaded by Android Studio and starting to play around with its APIs. With a bit of refactoring, we were able to extract the bits of the layout rendering library known as layoutlib, and borrowed some ideas from the Android Gradle plugin so that we can run the entire rendering pipeline similar to Layout Inspector, but on the JVM. And so therefore, we can completely bypass the entire device and emulator process. So instead of the usual build times I outlined before, running a JVM-based unit test takes a matter of seconds. Of course, your mileage will vary. Now, instead of running all the bits of this tool chain, we only have to run this. We don't have to do dexing. We don't have to do AAPT merging. We don't have to do proguarding, or R8. So we're able to only reduce it to compile the source for the tests and compile the layout resources in order to get r.jar, and then we can populate our UI with a view model. So 2 years ago, we named the project Paparazzi and released an early version of it, selling it as it's 100% Kotlin to help accelerate your Android development. So let's take a look at what this looks like. First, Paparazzi is implemented as a JUnit rule, and so you instantiate it with suitable defaults. We'll dig into more later on how you can customize it. And then you use Paparazzi as your inflation. It provides the handle to the context, which I'll dig in a bit more in a bit. So you'll either inflate your view or instantiate your view. And then finally, pass it to Paparazzi via a snapshot method. I won't be talking about it today, but we also offer a video file so that animation frames can be rendered as well, and you can do frame diffing. But for the purpose of this talk, we're going to be focusing on the snapshot method only. So now, you have your module, you run it in the command line, and at the moment, what you see is a web page like this. We intend to take a lesson from Spoon. Who here has used Spoon in the past for Android instrumentation tests? Okay, so the goal is to basically deprecate Spoon and endorse Paparazzi as the way of doing your CI test builds. Because right now, while there is a place for Espresso UI tests, you're probably using them for things that you don't need to, like snapshot testing. And so if you can minimize that, your testing pyramid should really have, I would argue, end-to-end integration tests for the very happy path, important flows of your app, but those should be in the less than 100. And you should really be leaning on more unit tests. But aside from that soapbox opinion, this is how it would look in the web page at the moment. It's pretty basic. When you're done iterating on your view, you can then record it, and it will persist the snapshot in a predefined location, which is also customizable. And the point of this is then you will commit it into source control as the source of truth of what this rendered view should be. Then on CI or on your command line, there will be a verification task that makes sure that the source of truth hasn't iterated. Updating a theme on a button in one screen and forgot that it actually changed another screen, now CI will tell you that you regressed. In this trivial example, you'll see that I intentionally wrote the snapshot with my nickname, and the diff shows you where is the change as a result of the verify task. And so this is a little more obvious, but we'll see examples where it can be more subtle. Another thing, who's used Square Burst as a testing library? So Square Burst was our attempt to parameterize JUnit tests where you can essentially go through permutations of different state. We've since deprecated that because Google's released the test parameter injector library, which pretty much does everything that Burst did and a whole lot more. It's just better. So we've deprecated it, and if you haven't used it, you should consider using it. It actually makes paparazzi testing even better. Say, for example, that you want to test over a variety of device matrices, say the new Pixel 6 that's coming out. And maybe you've also implemented light mode and dark mode, because isn't every app except Twitter doing that these days? So now you can use test parameter injector to iterate over these device matrices, again, similar to how we're invoking it before. And this is how we'd set up the enum. And that's how we would pass, in every iteration of that test method call, the appropriate parameters for the theme and the config. And we would now get a web page that shows us both theming with the action bar or without the action bar, or on different landscape devices, like so. Without going too much into how Cash App does architecture, many of you probably face a very similar concept of separating your business logic from your views. We have an internal framework that we are hoping to open source soon. But for the purpose of this talk, we basically define interface contracts for what a presenter and a UI, what their roles are, using unidirectional data flow, where a view click or a view scroll will be represented by some event and will ultimately update the view with some sort of model. Nothing new. But having these contracts in place makes paparazzi testing even easier, because now you've moved all the business logic, hopefully, out of your view, and you can just pass it a dumb model, essentially setting metadata, and it'll take it from there. And so a lot of our views look like this at this point, and writing the analog in test code looks like this. You'll see that now I'm starting to use more of the properties of paparazzi to customize things like theming. Another thing we're looking to do, this is an internal Snapshot browser that we use to show how the iOS version of the app and the Android app compares. Really helpful for our design team to catch where a certain widget may appear on several screens, and also sometimes if we're not looking, we'll notice that we didn't implement the view in the right way. And so this is what we have internally. We're hoping to open source that, but you can see already some of the benefits that we get from having an array of snapshot tests already committed. So that's surface level. Let's look behind the curtain a bit on how paparazzi is implemented. And so we talked about it being a JUnit rule. And so that's where most of the paparazzi logic exists. I alluded to layout lib. Paparazzi leans heavily on basically what drives a layout inspector. Bundled in layout lib is some portion of the Android framework. And then there's, except for certain parts of the Android framework, which essentially is mocked out and moves to these delegate classes. And I'm going to go into detail on that. But first, let's dig more into layout lib. If you've been doing Android for a while, layout preview has been around since API 5, back when Eclipse was your IDE of choice, and the Android developer toolchain was how you essentially did Android code. And the Maven Android plugin was a thing before Gradle. But even today, now that we're using Android Studio or IntelliJ and Gradle as the tools of choice, Layout Inspector is still present. A natural question you might ask is, how does this actually work? For example, Android devices, or the Android framework, has native calls which will actually draw to a graphics pipeline on a device. There's a lot of interactions with hardware. How does it load it into the IDE? And so it turns out what layout lib does is it provides this bridge. And this bridge provides two methods, an init and a render session. Let's go into the render session. And while I'm not going to walk through this code line by line, The things that you'll start to notice are there's a concept of a context here. It's called a bridge context. A bridge inflator, so okay, we're starting to see some of the Android ecosystem come into play. And then finally, a layout pull parser, implemented as a bridge XML block parser. And if you're familiar with Android internals, you know that typically when you inflate resources, a layout resource, you're using XML pull parsers. So what's the difference there? So if you unzip your APK and actually try to look at one of these resources, you'll see that, let's let Keynote catch up. You'll see that it'll look like this at your terminal, and that's because for efficiency reasons, size of APK, launch speeds, that XML is transformed in some binary format. And you can still grok some of the attributes in there, but for the most part, it's not meant for human readability. In layout lib, since we're not having to package an APK anymore, we're trying to read the resources directly from the file system in the IntelliJ project pane. And so that would make sense why the layout inflator implementation is different. Let's talk now more about those delegate classes. So layout lib is a very interesting project that I discovered in this process. There's a bytecode transformation process that's run over the Android framework, android.jar. And there's some DSL configuration that tells this bytecode transformation, anything that is a native call, swap it out. And this is where you can find if you want to dig in more. And so what do I mean by swapping out? So with the delegate class, if we look at an example like resources get drawable, this is how it's implemented on Android 29. But once layout lib processes it, it renames the original get drawable method to be suffixed with _original and puts its own implementation of that get drawable method, which you'll see kind of delegates, reroutes it to another implementation of resources. And so this makes sense. You're not going to do the binary loading of resources. You're going to do it in the file system. So there needs to be some code that runs that. Meanwhile, this is how resources delegate will look. And so it's a little painful to debug because all of a sudden your stack traces will not line up. But this is how the magic of layout lib occurs, where it can run off device. And so now if you look inside the jar file of layout lib, you'll see that this delegate pattern is used everywhere. Now, I say everywhere, but as of Android Studio 4.1, the layout lib that was bundled into that changed somewhat. It turns out that while you can delegate things like XML parsing fairly easily, things like font metrics were really hard to do, or had to be rewritten. For example, balanced text. The calculation of line breaks is done in native code. And so there are regressions where you may have noticed in Layout Inspector where line height and letter spacing just weren't rendering correctly. And it was a kind of a whack-a-mole game that Google had to play where every release of Android Studio would make Layout Inspector better. But really, they were writing two code paths, the Android Framework code path and then Layout Lib's kind of workaround. And so the team had a great idea. They said, well, why don't we just load the Android runtime in native code through JNI? And so that reduced the friction of that. Another thing to mention on fonts is layout lib was relying on the JVM font metrics, and it turns out that the JDK8, which for a while was kind of the version of the JDK you had to build Android with, had a different implementation of leading and ascender calculations, and it even differed depending on your operating system. And so early Paparazzi development, if you followed on the repo, I would have a snapshot file recorded on a Mac OS, and then it would fail a CI build, which runs on Ubuntu, because the JVM font metrics were just different, calculated by the respective JVMs. By moving to native layout lib, those problems go away. You get pixel perfect accuracy. Here's a great example. Who can see the difference between these two files, these two snapshots? I couldn't. How about now? These are the subtle differences that like the native runtime brought. It was kind of close, and you might have even said it's good enough, but I'm pretty sure your design team wouldn't have accepted that because there's just subtle differences in the letter spacing here. So let's go up the stack and now look at Paparazzi a bit more. So Paparazzi aims to be configurable to however you wish to test your app. it also aims to provide reasonable defaults. For example, Snapshot handler, depending on the mode that you run it in test, verify, or record, will either generate the HTML web page, or on CI, which has no reason to generate the report, will simply do verification, a JUnit assertion. If we look at this environment, we'll see that it passes a bunch of paths to layout lib, basically informing it where all the things are, where are assets, where, again, because this is driven off of the IntelliJ project, it needs to know where these things are. By following the conventions, you'll be rewarded because all these things will be found for you, but again, you can customize it to you as you see fit. One thing to point out is Paparazzi's environment is driven by this test resources file. If you've worked with RoboElectric in the past, you may have noticed that, I don't know, RoboElectric 2 or 3 used to also have a properties file where you had to almost point it to your transitive dependencies outside of what Gradle's configuration setup would look like. Taking a lesson from newer RoboElectric and also playing around with just Gradle in general, it turns out you can get all this information automatically and generate it. So Paparazzi has a plugin, Gradle plugin, to handle that for it. It's pretty basic. It spits out a text file, but how it works is it hooks into the Android Gradle plugin tasks, specifically the merge resource task, because while it's looking at the file system, you are going to have third-party libraries that provide resources. And so what you really want is the merge resources folder. And the Android Gradle plugin knows what that is. But you still need this to happen before compilation. A similar process is done for the Java compiler because there are things like Dagger that still have to run on the Java compiler pass, and also merge assets. So the way that it works is, in this case, is merge resources will spit out the location of where the merge resources are located. This task will then write them to this file. And then later on, when you're running your unit test, Paparazzi is going to expect that file to be there in order to preload its environment. Paparazzi also heavily makes use of system properties, Java system properties. So much so that it turns out that the Gradle test task can be multi-purpose. There's a lot of similarity between record, verify, and test. And in fact, from the IDE's perspective, it's really running a method in a JUnit runner. So using a system property can basically fork the conditional logic of how that test is going to run without having to rewrite the test logic that backs it. With the presence of this plugin, we can now move to a direct dependency on the Paparazzi library to the common plugin setup that we are familiar with in Gradle land. As I mentioned earlier, Paparazzi went from a purely JVM-based implementation to something more native. And so if you take a look at the Git repo on Google's source that basically provides that, you'll see here you are, the shared libraries from the native platforms that it supports. And that's what we talked about in that runtime section there. So here's where they live. And so what Paparazzi does, it redistributes them on Maven Central, wrapped in these jars. Now, before I go there, and if you look at your Gradle cache, you'll see that after you download Paparazzi, sure enough, the native libraries will be in your Gradle cache as well, so that you only have to download it once. They're pretty heavyweight, in the order of I think, hundreds of megabytes, so you definitely don't want to download that on every test build. Now, a keen eye would have noticed that this bridge init method takes in paths. While in the native live dir path and the ICU data path all live in your Gradle cache, but it's bundled into a jar. And so how do you actually extract these from the jar in order to pass it to the bridge? Are you, on every test, unzipping a jar? What happens if you have multiple projects that have Paparazzi? Are they going to unzip on every test method? That would be wasteful. But it turns out Gradle has a really cool trick where you can do artifact transforms. If you ever use Jetifier, an artifact transform is how Jetifier is implemented. It takes your support library binary, or your dependency, It looks inside for the resources, the class files, and rewrites that into a new version of that dependency. It's similar to if you shadowed a jar. And so that output is a transformation of the dependency, and it doesn't live in the cache, it lives in the transform. And from Gradle's perspective now, similar to if it sees a dependency is in its cache, it won't re-download it. If it knows a dependency has been transformed, it won't retransform it again, but it'll already be cached in your file system. And so if we take a look at what gets transformed, we'll see here now, those are the transform exploded shared libraries that were downloaded from Maven Central, and now we have file paths that we can pass to Paparazzi's bridge method efficiently. What if you don't use Gradle? Well, that's where the use of Java system properties came in by design. Some engineers at Spotify reached out to us early on and say, hey, we really like Paparazzi's potential, but we don't use Gradle in all of our builds. Would you be open to designing this where if we wrote a Bazel plugin at some point in the future, it would just work? And so while we're not on the Cash App team planning to write a Bazel plugin anytime soon, there is demand for one. So if anyone would love to contribute it and is particularly well-versed in Bazel, we will accept a pull request. One of the focuses we've had, and I'm sure many of you have had, has been on accessibility. With Paparazzi, you can also start to set up accessibility style tests. A very easy one would be just to see if your app can handle scaling of fonts. And so what we use is we take the Paparazzi context and we wrap it similar to how context theme wrapper would work. We have our own theming system in place of the Android theming system. It's actually quite similar to what Compose theming looks like, but we wanted that type of theming earlier. And so this is how we handle it. We also have a utility method called scrolling snapshot that if you have a scrollable view, we'll be able to stitch together images from many parts of the scroll. And so here's a real use in the banking portion of Cash App that offers direct deposit setup. And we see that the test can quickly show us whether we're handling wrapping or font size scalability in a certain way, in the right way. But even better, a member of my team, Jeff, realized that we have an iOS repo called Accessibility Snapshot that provides the functionality of taking snapshots and also walking the view hierarchy for accessibility absences. And so we decided, why not implement something like that? We generified it for something called a render extension, which will simply allow us to take the image that Paparazzi gave us and layer another image on top. It doesn't have to be used for accessibility per se. It can be used for any other purpose you see fit. But at the moment, our main use case is for accessibility. If you're interested in the details, here's the PR, and I'll post these slides after the talk. As I alluded to, the Cash App team on the iOS side already has an open source project like this for accessibility. So if either you dabble in iOS yourself or your iOS team may be interested in something like this, take a look at this repo. So this is the output of the accessibility snapshot, similar to iOS's. It'll crawl, as I said, your view hierarchy and highlight what's not present so that it'll just surface it earlier, because I don't know about you, but sometimes in a feature sprint, we're not necessarily thinking about all the accessibility things that we left out, and so unfortunately, we'll ship these things. Hopefully, this now allows us to do right by our customers. And so what changes in setting up the test is a one-liner. Just say that, hey, you want to now pass an accessibility render extension, and Paparazzi will render what you saw on the previous screen. One admittedly frustrating part is that layout lib bugs become Paparazzi bugs. And AOSP, by its nature, is open source, so yes, we can submit pull requests, but the Android Studio feature delivery sprints have their own cadence, and so we're all busy, and I don't expect them to necessarily review every PR. So what do we do when we bump layout lib and we have bugs like this? Well, then we try to rely on things similar to how Makito and RoboElectric used it. If you're familiar with how RoboElectric shadows work, internally it uses ByteBuddy, a bytecode transformation, to intercept method calls that would normally go to the Android framework and implement it differently. It turns out that, for example, when bumping to layout lib 4.1, matrix multiplication in the matrix clash was not present, and it's kind of like left undone in native code. By writing interception and essentially stealing code from RoboElectric, we could bridge that gap and allow for matrix multiplication to occur. It's also helpful for things like when you use Android X resources. If you call get font, it'll implement some of the code paths differently. Remember, layout lib will mock out the Android framework, but Android X libraries aren't eligible for that. So if you're calling Android X libraries and they happen to do separate code paths, you may not necessarily have the behavior you want. Layout lib won't know about it. And so for things like that, this can also be handy. Lastly, if you are using view as an edit mode, that made sense in Layout Inspector, but you don't want that actually in Paparazzi. You want it to act like the view looks in your app, not all the workarounds you did in Layout Inspector. And so we can intercept that variable and essentially negate it. Now, of course, I talked about view inflation, and here we are in a Jetpack Compose world. Does Paparazzi support that? Well, if you saw the title of this talk, it was called Paparazzi 1.0. My hopes was actually to push a button and release it today. But I'll have to say coming soon, in the order of like a week, 2 weeks. The reason for that is Compose support came in Android Studio 4.2. And as I mentioned, Paparazzi is currently in layout lib 4.1. After 4.2 is Arctic Fox, and there weren't too many changes from what I can tell from the commit history. But 4.2, in order to provide Compose support, did a pretty big refactoring of how Choreographer works. And if you're familiar with Android internals, Choreographer is pretty important. And so that migration broke a lot of things like animations for us. And trying to figure out how to invoke it properly is not fully done. It's like about 95% done. And if you want to hold me accountable, that's the branch that I push. It passes CI, so I thought that I was really close to pushing 1.0, but when I pushed an internal build to Cash App, I broke some tests, which is why we're not delivering 1.0 today. But like I said, it's my goal to get it there in the order of weeks, because internally we are also aggressively working with Compose for both client-side and also for server-side Compose, which it would be an interesting project when we finally open source it to the world. And that's the talk. I'll be around for questions off stage. Please, if you have any questions, are interested in using it, or have feature requests, I'd love to hear from you. Thank you.